Okay, hello everyone, and welcome to this session. My name is Moore, and I will be hosting this webinar. Today, we're going to be talking about building an internal developer portal to manage software development lifecycle with a serverless architecture. Should be about 30 minutes, give or take, and we'll have some slides, and then it's going to be a live demo of the product and how it interacts with AWS and the serverless architecture over AWS. And let's get started. Also, during the session, feel free to ask any questions you'll have. I'll try to get to them during the session, but even if I don't, there will be dedicated time for a Q&A session when we're done. Okay, so first, a bit about me. My name is Moore. I'm a lead architect at Port. I have a software engineering background. Over the past few months, I've hosted several webinars for Port, as well as some sessions for the CNCF, including Introduction to Developer Experience and how to abstract Kubernetes with developer portals. I really love video games, bouldering, and burgers. People around the office always ask me about the best places to go to, and I always have some witty comment or recommendation. So if you're ever in the Tel Aviv area, feel free to message me, and I'll be happy to help. Also, in case you want to contact me once the session is done, these are my contact information. And also, in case you miss some part, you want to repeat, you want to watch it again or send it to your friends, have no worries. The session is recorded and it will be sent to you once it's done. Okay, so what are we going to talk about today? We went through the intro, and now we're going to talk about managing the software development lifecycle of a serverless architecture using developer portals. We're going to talk about some of the benefits and pitfalls of serverless and serverless architectures. And we're talking about how to avoid those pitfalls and bring a solution in the form of a developer portal and self-service actions powered by Port's AWS Exporter. Then we're going to have a live coding session showing the way Port integrates with your AWS infrastructure. And we're going to have time for some Q&A. So first of all, I want to go over what we at Port believe should be the main pillars of a software developer portal. And the first pillar is the software catalog. The software catalog is meant to store all of the information and really be a way for you to map how your infrastructure and how your assets look from an R&D and infrastructure and DevOps and developer standpoint. It's supposed to give you that visibility layer that gives you the answer to all of the questions, such as who is the current on-call, in which region is my Lambda function, what topics or SQs does it maybe get triggered by, so on and so forth. And it's really meant to give you that bird's eye view that you can drill into to get the basic understanding of how your software looks, and also get all of the information in one place without having to search around too much. The second pillar is the self-service pillar. We want to give developers more independence and reduce the need for Slack messages and emails and requests, or just finding the nearest DevOps engineer in the hallway to ask for some mundane task that you've probably asked for a bunch of times, and the DevOps already have that ready-made script that they just need to press execute on. We want to save you that trouble and give you the way to invoke that script on your own without understanding too much what's going in the background or maybe the exact configuration that you need to go with. We want to give you that golden path to gain more independence in the R&D infrastructure. Next, we have the workflow automation layer, which is meant to actually give machines the power to consume the software catalog and the developer portal features. Over time, we saw that companies use the great information that they ingest into the software catalog as a way to let their CI/CD or their deployments or just their running services and APIs make decisions, make calls, all of these sorts of things. Because the software catalog is always up to date and always contains an API which gives you the latest information in a very easy to consume way. So we see a lot of companies use it as a source for their CI/CD and their automated processes. Then we have scorecards, which are a way to actually drive innovation and make sure that all of the services and all of your infrastructure is up to the highest standards. So for example, you can start creating categories for DORA metrics, deployment frequency, production readiness, security readiness, and actually start looking at all of your services one by one and saying, okay, is this service up to the standards that I should adhere to? Is it following the best practices that the organization has set? And so on. And actually look at those services, see who is maybe not at the gold tier just yet, and how you can push it to that state. And that is a very great way to, first of all, keep track of what services need attention and need some triage maybe, and also which services can be a good example to use when trying to push the organization standards even higher. Now, accompanying all of this is the role-based access control layer, which is meant to, first of all, reduce the cognitive load by controlling who sees what information. We don't want that one developer getting full view into the entire infrastructure. It is probably too much of a drill down for him. He probably doesn't care that much about every single pod in your Kubernetes or every Lambda function that you have, but he probably has his own microservices that he's responsible for or that he interacts with quite frequently. And he probably wants to see those in a way that is concise and in a way that is easily digestible for him. And extending on that logic, we also want to use the self-service pillar, but we want to make sure that only the correct personas can invoke the right actions. So for example, the DevOps or platform engineer might need access to a restart Kubernetes cluster action, but we don't want every single other developer to have access to that action because that is quite an extreme one. But he probably does need access to an action to roll back a service version or maybe change the replica count of a service to make sure that he can maintain his application as it's running without getting too much help from DevOps. Now, all of these features of the developer portal can be consumed via a UI, API, or ChatOps interface. And once all of these pillars are in place, and all of that excellent data is up to date and ingested in real time into the developer portal, you can use it to generate R&D insights and reports. Things such as what are the services that are not up to our standards based on the scorecards and might need some attention to bring them up to par. Okay, now let's talk about serverless, which is why we're gathered here today. So first of all, serverless can be incredibly simple and efficient. You do not need to deploy and maintain a complex architecture or maintain the services on your own. You do not need to care about a physical or virtual machine or even a Kubernetes cluster. It scales automatically according to your needs, and as your application receives more traffic or your functions gain more traffic, it auto scales and it will almost always have enough capacity for you. And the process is incredibly simple. You just upload your code and you're good to go and don't need to give too much thought into how things are working in the background. Mostly your cloud provider is doing most of the heavy lifting for you. You just give it the code and you're good to go. And because this is something that is native to the cloud providers, it integrates naturally with the rest of your cloud infrastructure. If you're using other services from your cloud provider, the logs, the queues, the different triggers and API gateways all integrate with your Lambda functions and your serverless functions seamlessly. And all of this is incredibly powerful. It makes it very easy to go from a small code sample or a prototype on your machine to something that is running in the cloud. It's highly available, it's highly scalable, and it's all very easy. But because everything is so easy, it also poses some new challenges. So keeping track of everything can be difficult because you have less overhead and you need to maintain less. It can be very easy to just prop up a bunch of new Lambda functions or new serverless resources and forget about them, or maybe forget why you deployed them in the first place. Maybe you stop maintaining them and then at some point you need them or need to do some triage or fixes, and it can be very hard to keep track if you dive super into serverless without making sure you have the correct controls and documentation in place, which is going to the second bullet, which is saying if not documented properly, eventually you're going to have a bunch of Lambda functions, maybe in even in different cloud accounts or cloud regions, and it's going to be very hard to understand what the hell is going on, and how am I supposed to find the correct function that I'm looking for? How can I find the correct thing that invokes it or triggers it? Or why am I not able to use its permissions to perform a certain task? And these are only some of the challenges, but if not taken care of, it can really become overbearing and overwhelming. And it's really a common pitfall that we see companies saying, we have so many things in the cloud right now, and we're not exactly sure what belongs to what service and what architecture, and really do need something to help us keep track of everything. So exactly for those reasons, we have developer portals and Port. So a developer portal makes it really easy to keep track of your complete serverless architecture. As we'll see in the live demo, I'm going to start from a completely blank developer portal and start mapping my AWS account into it. And you'll see that in just a few minutes, I'll have a complete map of how my cloud region looks. In addition, it's going to help us see the connections between the different components. What SQ is triggering my Lambda, what S3 bucket am I using, and also connect all of the dots and expose serverless abilities with those tools. Now, another great benefit is that the developer portal and its AWS Exporter are automatic and immediate, meaning your architecture map is always up to date, either via scheduling or via event rules, which make it very easy to keep the developer portal up to date and always have that most up-to-date mapping of how my infrastructure looks, how my cloud environment looks, and that way always being on top of things. And like I said, as the last thing, we're going to expose some self-service actions that go from the developer portal to our cloud infrastructure, and we'll show how easy it is to give your developers more control over what's happening in the cloud, and taking advantage of all the great resources that we have in the cloud, without having to work too hard or finding a DevOps engineer that will help them out with that. So let's first of all examine the architecture that we're going to take a look at. So like I said, we're going to use Port's AWS Exporter. By the way, you can learn more about the Exporter in our documentation, and also the Exporter is completely open source. You can go ahead and examine the code and see how everything is working in the background. But the main process is we're going to deploy our AWS Exporter on an AWS account. The Exporter will create an S3 bucket, create a new Lambda function, create an SQ to get new events. And then what's going to happen every time the Exporter is triggered is going to contact the AWS Cloud Control API. And then it's going to, and the Cloud Control API contains information about all of the changes that happened in the different AWS resources. So our API gateways, SQS, Lambda, ECS, App Runner, EC2, whatever resource from AWS you can think of, those changes go into the Cloud Control API. And the AWS Exporter can query those different events and changes and simply ingest them into the software catalog, making sure that Port always has the most up-to-date mapping of how your cloud looks inside your developer portal. So now we're going to go to the live coding session. What we're going to do is we're going to deploy Port's AWS Exporter. And while that is happening, I'm going to explain a bit more about the process that's happening in the background. And also I'm going to explore our self-service action example, because that process does take a few minutes. And then we're just going to go through the example. We're going to extend the AWS template with some more resources. We're going to set up an action, and we're going to see how we trigger that action and view the result in Port's software catalog. So here is my blank port. It's just a blank account. And what I want to do is I want to start working with the AWS template. So I'm going to go to the template center, and I'm going to choose the Map Your Cloud Ecosystem template. And today we'll be focusing on AWS, but we do have GCP and Azure support coming real soon. So stay tuned for that. What I'm going to do is I'm going to click on Get This Template. What's going to happen is that Port is going to create some initial blueprints for me. You can see in the background, we have a blueprint for App Runner, Lambda, ECS, and Region, which is a bit hidden here in the background. And now that I have the template started, I have a request to run this script. What this script is going to do is it's going to install Port's AWS Exporter on my AWS account. So let's quickly go into that. So I'm just switching to my terminal so you can see what's happening. There we go. So I'm going to paste this script in. I'm going to let it run. And now this script takes a few minutes to get started. It's going to deploy some resources in my AWS account. So while that is happening, just so we can continue to explore the example while it's making its deployment, which should take about 4 to 5 minutes, what I'm going to do is explore our self-service example. So the self-service example is going to trigger an action in Port from the UI interface. That action will go to Port, which will create a payload from the inputs that we specify in the action, and send that payload as a post request to an API gateway that I have set up beforehand. That API gateway will send that payload to an SQSQ, which is going to be received by a Lambda. And that Lambda, once it has that payload, it can do whatever you might need. It can return a response. It can maybe trigger some additional logic. It can create or save a file to a bucket, maybe create a secret, or deploy some new resource in AWS. So from there, you can really do whatever you want with that information. And the idea is that the action is completely customizable by you. So you can specify whatever inputs you need and use them to make very complex tasks if you want, or you can have just a simple trigger that has no inputs at all and just restarts the service or rolls back a version or performs something really simple. The choice is yours. And once this action is running, it can also send information back to Port, such as displaying the logs of the running action, or sending a link to what actual workload is running in the background, and also set the status of the action. So that way, if you expose an action to your developers, you give them the option to understand what is happening as that action is running directly from Port, without having to give them access to specific CloudWatch logs that might confuse them or be too verbose for them, and generally without giving them too many permissions, and keeping the role-based access control layer in Port as the gateway to what your users see. So we'll get to that part in just a few minutes. In the meantime, I can see that the Explorer is still in deployment. So while that is happening, let's start exploring what we got from the template. So every box that you see here is what we call a blueprint. And a blueprint is a completely customizable object in Port, which you can use to model how your data looks. So if I go ahead and expand the Lambda blueprint, you can see here a different set of properties that come out of the box with the AWS template. But these set of properties are completely customizable by you, and you can decide to add new properties or remove certain properties that you might not care about. And we support all major types, arrays, enums, JSON objects, YAMLs, numbers, and so on. And you can even create properties that are a calculation or some sort of function over the different properties that you have in your blueprint. And basically, once you have your blueprints in place, you can use relations, as you see this arrow that goes from Lambda to region here, to actually map a dependency on what's going on in your data model and in your architecture. So I'm going to show it a bit later once we have some information in place, but we'll be able to go to the region blueprint and look at a specific region, for example, EU West 1, and see, okay, what are all of the different resources that I have deployed in my EU West 1 region? And we'll be able to visualize it both in a table manner and also in a graph view, which is going to make it very easy to understand what is happening and what is going on, and really diving into every little thing if we want to, but also getting a great bird's eye view of how my cloud infrastructure looks, and where are my things deployed and what connects to what. So I can see that the deployment is almost complete. I'm just going to give it a few more seconds. Also, if you guys have any questions, feel free to ask them in the chat. And now is a good time because we have some downtime. Also, in the meantime, let's explore a bit the visual editor for the blueprints. And this is a new feature that we deployed quite recently. And so far, our users have been very happy with it. So you see this blueprint right here, and say I want to add a new property. So let's, for example, say I want to add a count property. So it is super easy. I can just specify the title of the property that I want, and I can enter a description and then choose a specific icon. And I can also specify the exact type. And I also have some validation options to actually make sure that I give the correct guardrails to my developers and to the teams that interact with the developer portal to make sure that everything is according to the standards that I set. So I can see that we have some data flowing in, and the exporter has been deployed successfully. Over on my terminal, I can also see a tail of the logs of the Lambda function that is deployed with the exporter. I'm going to expand it a bit just so you can see a bit better. So this is just the live log of what the exporter is doing in real time. The exporter starts with an initial run, which imports the default resources that you see here in the template. So if we go ahead and explore what information we got, so first of all, in my environment, I do not have ECS or app runner instances, so these tables will be empty. But what I do see is the 3 Lambda functions that I do have. So these two are related to the self-service actions example that I'm going to show a bit later. But this here is the port AWS Exporter, which we just deployed. And as I said, it is a simple Lambda function, which uses the Cloud Control API to ingest information. And you can see here that we got a bunch of information, such as the tags, the architecture, the environment variables, and layers that this Lambda function uses. And we basically got all of this right out of the box. We didn't really need to do anything except for deploying the exporter. And what I want to do now is I want to add a few more resources to extend this example. So what I'm going to do is I'm going to add some more blueprints. So first I'm going to add an S3 blueprint. And excuse me for using the JSON editor for blueprint. It's just going to be a bit faster. So there we go. We have an S3 bucket blueprint. And also, it's important to note that all of these blueprints that I'm adding are available straight from our documentation. If you need some inspiration into how to model your blueprints or what fields you can get from the exporter as you're deploying things, this is a great way to do that. Simply grab the latest version of the blueprint from our documentation and extend it as you see fit. And this is the last blueprint I'm going to add for now. So just to recap, I added an S3 bucket blueprint, an SQS blueprint, and an API gateway blueprint, because these are all of the resources that I'm going to update the exporter to look at now. And speaking of updating the exporter, let's take a look at how the AWS Exporter's configuration looks. So the idea is that it is a simple JSON file with a resources array, and every object in this array selects a specific kind from the AWS API, which the exporter Lambda can then read and map into an entity, which is an instance of a blueprint inside port. So you can see here the default configuration of the exporter from the template brings us a Lambda and App Runner and ECS services. But what I've added here, which is new and different from the basic example, is I've added an SQSQ and API gateway, REST API and API gateway API v2, and S3 bucket. And again, these new kinds or objects from the AWS API, we do have configurations for those in our documentation. So if you start with the basic example, with the basic template, you just go to documentation, you grab the config for your specific example, and we have a bunch of examples for plenty of AWS resources. You just add it to the general config, and you upload it to the S3 bucket of the exporter, which I'm going to do just now. So I have a tiny script to do that. And also, I see a question from David. Do the blueprints need to be added before the AWS Exporter is able to export them? Or is there an option for the exporter to define the blueprint itself? So at the moment, the blueprints do need to be defined in order for the exporter to be able to ingest information into them. We do have plans to separate the blueprints model from the ingest. So maybe when the exporter detects a resource, it ingests it in and the blueprint gets inferred from the information. But at the moment, you do need to create the initial blueprint that you start with. And the exporter can report some of the information or make a partial report maybe, and you can tailor that to how it's convenient for you to work. So we've updated the exporter using just a simple S3 CP command, which uploads the new config to the exporter bucket. And what's going to happen now is I'm going to trigger the exporter again. And now the exporter can work with an automatic trigger, either via a schedule or via event bridge rules. But this takes a bit more setup, and I didn't want us to go through all of that process because it's pretty similar. So I just uploaded the new config, and I'm going to manually trigger the exporter's Lambda again. And what it's going to do in the background, it's going to pull that new configuration, and it's going to ingest all of the new resources. So for example, you can see that it's scanning for SQSQs and REST APIs and so on. And now if we go back to port and we look at SQS, for example, then we can see our new queues, which were reported just a few seconds ago, as well as our S3 bucket in that account, and our API gateway, which we're going to use for the self-service example. And also, if we go ahead and say, I want to see everything that I have in the EU West 1 region, so I can simply click on the region, And in the related entities section, I'll see all the different blueprints that are connected to my region, and also all the different entities from AWS that I have in that region. And let's say I want to have a graphical view to really understand how are things interacting inside my region. So I can do that very easily and see everything and dive into whatever I might care about. And it also works in the other way. So if I'm now looking at the AWS Exporter Lambda, I can look at the graph view and see it is connected to the EU West 1 region. So, and this shows us the power of the AWS Exporter, but we're not done just yet. I promise that we're going to do a bit of self-service. So in order to do that, I'm going to add another blueprint, which I call the notification blueprint. So let's add that in. And we're also going to add an action. And I'm going to explore a bit how that action looks and how it behaves. So what we can see here is the structure of an action. And again, you can find this structure in our documentation. And this action will send a new notification. I specified as user input the option to enter a message. And it's going to use the webhook invocation method, which means a port is going to take the payload and send it as a post request to this URL, which in this instance is my API gateway, which is meant to receive that payload. So once I go ahead and click save on that, if I go to the self-service hub, I will see my new action. And let's say I want to send a new notification now. So let's say hello from webinar and trigger that. Let's add a smiley, why not? So once that is executed, we can see it here on the side menu. And if I go in and look at that action, well, it already completed. And we can also see the log of the run. So we can see these are messages that are sent from a Lambda function that is triggered at the end. And I'm gonna go and look over the architecture again, just to give us a small refresher. So the Lambda function said it received a message from the queue. These are the inputs it received. It generated just some random number by calling another Lambda just for the example. And that's it. This action has finished. And if we go to the affected entities tab, then we can actually see a new notification that was created. And we can also see a way that port helps us handle multiple invocations of actions. So for example, I used an SQS queue in this example, and SQS promises at least once delivery. But let's say I don't want my action to be invoked more than once. For instance, you can see here that the actual Lambda was triggered twice, but since port keeps track of which actions were completed, we can see that during the second attempt, we got a message that the action is already finished. So this is also a good way to make sure that functions only get triggered once, and we can actually go a bit closer to promising exactly once delivery, which can be very hard to implement sometimes. So now if I go to the notification table, I can see here the new notification. I can see the message. And again, this was simply sent from the Lambda function using a simple post request to ports API. And that actually shows us how very easily we can use self-service with our developer portal and exposing new abilities to our developers without having the need to expose the actual AWS infrastructure or giving them some specific IAM role or things like that. So again, just for a quick refresher, like we said, we triggered that notification action in port. Port generated that payload and sent it to the API gateway, which transferred it to SQS. Our Lambda received that payload. It called an extra Lambda function to generate a random number, and they reported back to port about the action status and also created that new notification entity. And then that's really it. Just to recap, we started with a completely blank developer portal, deployed our AWS template, and started making some additions to our AWS template to actually gain a better view into other resources that we have in our account and we want to see. And we made that update, and we also deployed a new action and used all of that to tie together into how we invoke from the developer portal our cloud infrastructure and gain that information back to have that complete view and have the actual mapping of how things are happening and how are things looking inside our cloud. And that is it. That is the session. If you guys have any more questions, feel free to type them in the chat. If you need some inspiration for how far a developer portal can go, you can check out demo.getport.io. It's a fully open and free demo. You do not need to type an email or sign up or anything like that. You can just browse there and look at things. And also, if you have other questions, feel free to email me or search for me on Twitter. And as I said before, the session will be recorded, so have no worries if you need to go over some things again or take another look. I see that we do have some questions, so let's answer them now. So David asks, do the resources that Port uses to run self-service show up as a service in the software catalog? So I'm going to open a page from our documentation to show a bit more how the self-service works. So the idea is here is a shared responsibility model. You configure import your action, and you specify what backend that action will go to. And that backend can be a webhook or an API or a GitHub workflow or a Jenkins pipeline or even a Kafka topic, because we provide our customers with a dedicated Kafka topic, which they can read the action messages from. And the idea is that once you trigger the action, Port wraps that payload and sends it to your desired backend. And once the message arrives at your backend, that is your responsibility to take care of it. So you can do that either with an API or a pipeline or a Lambda function. And that is actually how you get that payload, you parse it, and you decide what to do with it. So these resources, should you choose to document them, will appear in the developer portal. For example, as we've seen that my Lambda functions, which handle this self-service action that we configured, do appear in the portal and include all of their information. So hopefully that answers your question. Now, Sanachit asks, is it possible to implement blueprint deployments and config updates through a pull request-based workflow? Yes, that is 100% possible. We actually have another webinar already recorded and up on our YouTube channel that includes an example for that, where we take an action that opens a new pull request and makes an update to a Terraform resource definition. And that actually generates a new Terraform plan, which once merged, affects the infrastructure both in the cloud and inside the developer portal in Port. So I highly recommend checking that out. I believe that it will answer your needs. Arthur asks, is there a way to control what is displayed on the left menu? Yes. So it is possible to select which pages appear in this menu. Right now, it is available through API calls, but we are working on a new widget, which will allow you to make those changes via the web UI, so you don't have to get too confused with that. And also, Arthur asks, do all of the elements of the blueprint need to be displayed, and can we structure them? So as I said before, a blueprint is completely customizable by you, and you can choose to add or remove properties as you see fit. So for example, if the AWS template brings you the app runner blueprint and you don't care about the image identifier for some reason, you can just delete that and you stray away a bit from the default template. But that is your choice, and you're free to do that if you don't want to see that information inside the portal. But what I would recommend to do is to still keep that information in, but use our very strong pages and views mechanism to actually hide away the different things that you might not care about. So for example, maybe I don't care about the owning team of a Lambda function, or I don't care about its identifier or its memory size. So I can just hide those fields and save that view. And now everyone that goes into this page sees this curated view that I created. And so that way you can, on the one hand, keep all the information in the catalog, but only show in the table view the information that users you believe really care about. So I hope that answers your question. And Brad asked, how do you connect the new blueprint such as S3 back to the main AWS blueprint? I missed how that was done. Okay, so I'll go over that again. So what we did is remember that our initial AWS template gave us blueprints for region, app runner, Lambda, and ECS. And what I did was I added a new blueprint for S3, which I took from our documentation. I'll go ahead and show that just to make sure that we don't miss it. So we can see here the S3 blueprint, and this is the exact blueprint that I used in my example. And now after I added this blueprint in, I also updated the configuration of our exporter. So if we go ahead and look here, this is the current config deployed on my exporter. And what I've added is this AWS S3 bucket kind, which means that once the exporter runs and tries to gain the latest information from all the different resources that it's supposed to track, it's also going to ask the AWS Cloud Control API, hey, what is new with AWS S3 buckets? Give me that information. I'll turn it into entities in the developer portal. And so once I triggered the Lambda function again, it actually took that latest configuration, it brought that information for S3 buckets, and it created those entities inside our developer portal. So I hope that process is a bit more understandable now, and you managed to follow it. Also, remember that the recording will, this session is recorded, so you will be able to go over the explanation as many times as you need. And I see that we don't have any more questions. So thank you guys very much for joining me in this session. I hope you had a great time learning about how Port can help you with serverless architectures. And I really hope to see you guys in the next webinar, and have a great day.